we're going to start with learning objectives for time value of money. And the time value of money is sometimes a really hard concept, but we're looking at compounding and we're looking at interest and how interest paid on interest can really increase the value or the amount of funds that you are investing. So let's start here. First of all, we're going to look at the mechanics of compounding, and that's how money grows over time when it's invested. We're going to look at the relationship between compounding and bringing money back to its present value, because $100 today is worth more than theoretically $100 in 5 years, because you have to bring it back to present value. So we'll look at those relationships. We'll look at annuities. We're going to look at future and present value of a sum when there's non-annual compounding periods. What does that mean? That means when it pays quarterly, or it pays daily, or it compounds every 6 months. So not annual payments, but payments within the year. We're also going to look at an uneven stream of payments and how to calculate that. And finally, we'll look at the complications from trying to bring money back in an international setting with unpredictable inflation rates. And the principle that you find in this book from Chapter 1 is money has time value. As I said, $100 today is much different than $100 promised in 5 years. So, and that being is in 5 years there's uncertainty that even whether you will get it. So you would have to, you almost demand, okay, if you're going to give it to me in 5 years, I want to be compensated for that wait. And there's a calculation that you can use to take future value and bring it back to present value, or take present value and take it to future value. And that's what we're going to do. And the key terms we're going to use in this chapter that you really need to understand are the compound interest versus simple interest, future value of money versus present value, a timeline, and effective annual rate. And we're going to look at annuities, a compound annuity, an annuity due, an ordinary annuity, a perpetuity, which is really a cool word, isn't that nice? And an amortized loans. So that's kind of what we're going to look at as we go through this. I probably will do this in 2 sections because it could get rather long, and I don't like to have you sitting for over 15 minutes. So first of all, this is a timeline. And I'm not going to explain the process we've got here right now, but timeline is nothing more than the years and the cash flows that come from each one of those years, and we usually have the rate up here. And from this, we can do calculations, and we can organize our thinking about the value of money at different time periods. We'll be using these a lot. Now, let's start with some of the terms. Simple interest. That's interest earned on the principal only. An example, if I had $100, I invested it for 6 years, 3 years at 6%, and it was simple interest. I would just earn interest on the $100, not what has been accumulated, as compared to compound interest. And compound interest accumulates. So the first year of interest is $6 is added to the principal, and then the interest rate is applied to that full $106 for the next year to give you $112.36. For the third year, it's added up again to give you $119. So your interest earned for 3 years compound is $19.10, and your interest earned for simple is $18. Now, over the years, that accelerates considerably because the interest is building up in the principal. And that takes us to the future value of money. So if we have, what do we have here? We have a beautiful formula, and everybody's cringing right now. Never fear. We're going to use Excel to do these formulas, and I'll show you how to do those in a minute, but I want you to see the basic. What this is saying, the future value of some amount equals the present value times 1 plus R to N is a period, so if it were 5 years, it would be to the 5th power. And that's kind of what this explains, is the future amount of the investment in years. R is the interest rate, N is the number of years, and PV is the present value, or the original amount invested. And this is an example of it. You're going to invest $100 at 1 plus the rate to the 2nd power, and that will be worth $112 in $112.36 in the future. Now, let me show you the Excel way. So you can see here's the formula. It's equal future value of D2, D3, and D4. Now this is how you do this. First of all, you set this up with the rate, the years, and the present value. If you type in equal FV parentheses, it brings up what needs to be placed in this formula. So the first one is rate, then a comma, then the years, then a comma. Now our payment is, there's no payment. We're going for the lump sum. So I do a comma there to show that that's empty. And then the next one is PV, which is what this is. We put that in, and then we close the parentheses. And that should give us $112.36, which is exactly what the formula came up with. Right here. So Excel is very easy to use, and that's what we're going to use. But it's nice to know the basis of these. So now, what's the effect of this? Well, the effect isn't too much different as you're going up, but until you hit some, right here, look at here. See how things start accelerating after the 8th year, actually after the 7th year. See how they accelerate? That's because you're earning interest on interest, and that just really increases the return on that money. Here's that's a bar graph. Here it is in a line chart. You can see it hits about right here and then just takes off. So compounding is a really important concept to understand for investing money. And I just showed you that. I want you to know that you need to relax. We are going to use Excel to calculate this. We are doing some bond things that are very similar to this. We're going to use Excel. You're not going to have to crunch numbers. So just calm down. So if you want present value, this is the present value calculation. Let's say I want to know the current value of a future payment or receipt. Well, this is our formula. It equals the future value, 1 divided by the rate, okay? 1 plus the rate to the period power. And that looks like here. So we have a present, let's see, we want to know what the present value of 500 will be in 10 years with a discount rate of $6. So we're looking at the present value. They're saying you're going to have $500 in 10 years, 10 years at 6%, and you can see how this calculation comes down. If you do that in Excel, you would type in, let's look at this. Here's your formula, PV, D, and it's just like this one. But we're going to use, and this one used future value, this is going to use PV. So PV, and then I do my rate, I do a comma, I do my years, that's what in period is. It's asking for payment. I don't have payment. I have future value, 500. Close that up. Gives you 279.20, which is 279 what they came up here with a bit of a rounding factor. So now the reverse is true of this. As you see, you start with 100 and then that value goes down. It sags quite a bit. The further out you go to the end, that value comes down here. So the reverse is true with present value. So now we're going to look at how you use these. You'll use these for a future value of annuity or the present value of annuity or an annuity's due. Future value and present value of a regular annuity or of annuity is here. The payment is at the end of the period. With an annuity due, it's at the beginning of the period. I hope I said that right. I believe I did. And we'll find out later on. So stay tuned for that. So an annuity is a series of bonds of equal dollar amounts for a specific number of years, and an ordinary annuity occurs at the end of each period, where an annuity due, occurs at the beginning of the period. There's a difference in that and a different ratio or a different equation to use for it. And Excel does that also. So here's your calculation for that. So for each year, you would take it out. If we've got 5 years, this is looking at a 5-year, $500 annuity compounded at 6%. So you've got 4, 3, 2, 1. Everything's brought to the as far out as it can, and to the power. And then you do all of the calculations, and you come up with the future value of an annuity for 5 years at 6% is $2,818. Now, if we look at that here, you can see how this is calculated. There's for 1 period, there's for 2 period, there's for 3 period, there's for 4 period, and then the 5th period. And that is added up and comes up to 2818. You see how this time period is used when you're doing that. You're going into the future, so remember. Now, to do that, here, let's do that also. This is the future value of annuity, and this one is giving us the payment. So it's going to be different. So we're going to do equal FV. Again, you're going to do the rate, comma, the years, comma, and now you're going to do the payment, comma, and then it will calculate it very close to, there's always a little bit of difference in rounding, so this is 2818, and this is 2818.50. So using Excel speeds it up, but you can understand the mechanics of what it's doing here. Now, and that's the one we just did. Let's look at the present value of an annuity. How do you think that might work? Well, we're using a payment. It says equal payment of 1 minus 1 plus the rate to the -1 as the power divided by the rate. And that'll give you this factor. Keynote here, there are also tables that will give you these factors by simply looking up the rate in the period, and they're called time value tables. You can search for them on the internet and find them. They're very quick. A lot of accountants use those. This brings us up, so just a FYI, with a value of 2,106. Now, what does that look like in Excel? It's right here. Again, I have this set up, and we're going to use present value, D4, D15, and D16. So what is this telling us? So now I do equal PV. Again, if I go the rate, the period, and I believe that was a payment. I'm going to hope it is. And close that. That gives us $2,106 as the present value of an annuity of $500 for how many years? I think it was 5. Now, taking the timeline on that, you can see how we're doing it this way now. We're coming back. We're not going forward, we're coming back, and we're getting the present value of the annuity using a timeline, using this rate, using the calculations found here. So if you look at annuity due, now remember these were all at the end of the period, this is going to be at the beginning of the period, and let's see, how many more slides do we have? I think we'll end this one right here, and I'll come back and start with annuities due. I'm at 16 minutes, so that's a bit long to stare at a screen.